For this sync session assignment, I'll be addressing the topic of internet crimes that would require the skill of a network forensics investigator. This assignment is taken from the Practical Guide to Computer Forensics Investigations by Darren Hayes. Specifically, the intent is to conduct a search for crimes on the internet that I believe would require the skill of a network forensics investigator, and then to detail the nature of the network evidence that would have been helpful in the investigation. To do this, I want to start with a conclusion and then go into how that process would be accomplished. But in essence, there are not a lot of crimes on the internet that, if properly investigated, would not benefit from a network forensics investigator. Cyber forensics experts generally tend to focus on client computers and devices during investigations, and they get their server data evidence from a lot of different independent service providers. But that's the reason, and because advanced persistent threats are becoming more and more prevalent, that there's a new and unmet need for more network forensics examiners. But in essence, we're going to look at how the data would be captured, crimes that occur on the internet that would require a network forensic investigator, basically all attacks that would exploit any network vulnerability. And advanced cyber networks attacks succeed because they're carefully planned, methodical, and patient. So to do that, I'm going to break it down into the areas where a forensic analyst would start their process. So in order to detail the nature of the evidence that will help the cyber investigator, the playing field needs to be established. And the nature of evidence to be collected is whatever could be documented to have occurred, and then point back to whoever it is that started the action against the organization, whatever the malicious action or maybe an inadvertent harmful action, trying to find that out. But the first thing that you want to look at are devices that have logging capabilities, because those are the things that will right away give you information. Those include the list that you see on the site here, or on the page here. But from these sources, the network evidence can be pulled, and it's important to understand devices that have logging capabilities actually contain historical evidence. So understanding this would enable the investigator to know the different systems for each networking server or device in order to differentiate between all the server timestamps, which will differ depending on which one you're working on. Once they grasp that concept, the task then is to create a network log for the appropriate server or application. So the OSI standard, that's a model that's used to define how data is transmitted across the internet. The model uses layers to help give a visual description of what's going on in the network. This can help network managers narrow down problems. Is it a physical issue, or is it something with the application? As well as computer programmers, when developing an application, which other layer does it need to work with? The Open System Interconnection, OSI for short, was introduced in 1984 by the International Organization for Standardization. It was introduced with the notion that we communicate across the internet using these 7 layers that you see on the screen. The 7 layers encompass where the threats occur, and those are the areas that the network forensics investigator needs to be aware of in order to properly investigate a crime or an action. So what I mentioned earlier, advanced persistent threats are part of the reason that you need network forensics analysts and investigators. The idea here is that once this gets into the system, it's probably been there for a while, but as an investigator, first you want to be able to detect it and neutralize it. But again, first you need to be able to know that it's there. You want to be able to get the evidence to track down the origin and then prevent it from occurring again. So because this is the nature of the threat, there's a couple of methods that you would want to go about countering this threat. And specifically, we're going to look at the cyber kill chain and then looking at indicators of compromise. So the phases of the intrusion kill chain are listed here on this slide. That's what you're going to have to be working against when using the cyber kill chain. It's a series of steps that trace stages of a cyber attack from the early reconnaissance stage that you see at the top and goes all the way to the exfiltration of data. The kill chain helps us to understand and combat ransomware, security breaches, APTs. But it's evolved to better anticipate and recognize insider threats or social engineering, advanced ransomware, and other innovative types of attacks. So understanding where it's going to come about will allow us then to understand and ID the things that will let us know that there's an actual compromise. So they're so advanced now, though, that a lot of the traditional security mechanisms like firewalls, IDS, antivirus, cyber software, they're just not effective. But there are some trends, there are some tags, some evidence that's left behind from advanced persistent threats that will help the forensics investigator identify that there is a compromise. Those would include unusual outbound network traffic, anomalies in privileged user account activity, other login red flags, things that people are doing irregularly, swells in database read volume, inordinate size responses in your HTML, large number of requests for the same file. There's a list or huge checklist of items that you could go through to say, okay, here are the indicators that the network forensics investigator would be able to point to as why a compromise has occurred or how it came about. But your indicators of compromise, they're going to identify the malicious activity on your system, and they're going to help you detect data breaches, malware infection, or other types of threat activity. But by watching for them, any organization can detect and hopefully act quickly enough to prevent any of the breaches from occurring, or at least limit the damages by stopping the attacks as soon as possible. So to kind of wrap it up, one thing to also remain aware of is that not all of the APTs that we're looking to combat, that the network forensics investigator is going to be trying to detect, are attacks and breaches. Identifying a compromise can be really difficult because an attacker can move from computer to computer in an organization, or maybe just because an indicator of compromise can be hard to find. Finding small changes in like a maze of registry files can be nearly impossible if you don't have the training or experience to know what you're looking at. One of the best ways to identify a compromise is going to be to compare a system that you think is infected with an uninfected system. So to do that, you might take a computer that somebody hasn't logged on with in a while. Maybe they've been on leave, or maybe they've got a furlough, and then find that computer and then compare it to the infected computer. That'll make it a lot easier. Another way is to look at maybe restore points on your system and compare those with what the infected status is, or the infected computer status is. The status of the network based on what it is now versus what it was before. But the conclusion is really this. None of these solutions are going to be easily accomplished, which is why they require the skill of a network cybersecurity professional rather than someone who is just going to outsource that or just go with the evidence that's on the local devices. Thank you very much.